Fine. So I'm discussing today the ion selective electrodes. Basically, for your syllabus, it is glass electrode. Glass electrode, which selectively responds to what?
H plus ions.
Yes, H plus ions. Glass electrode selectively responds to H plus ions and develop potential with respect to H plus ions. And that developed potential is proportional to the concentration of H plus ions. Okay, this is what the ion selective, especially the glass electrode, is. Okay, so how it is constructed, we'll discuss now. Glass electrode. Glass electrode is also known as pH sensitive electrode. It responds to what? H plus ion concentration. Okay, if you change the H plus ion concentration, the potential, the voltage of this electrode changes. Glass electrode changes. So it's a sensor. Okay, pH sensor. Okay, glass electrode is also known as pH sensor, pH sensitive electrode, widely used for pH determinations. Okay, the glass electrode is symbolically represented as, this is the glass electrode representation. But you see, you don't have to remember this. You don't have to remember this. Okay, just see, it contains what? Silver. Okay, and it is coated with what? Ag is coated with AgCl. Okay, outside. Okay, and that AgCl is in contact with what?
HCl.
0.1 molar HCl. So that's how I have written. Silver wire is in contact with AgCl, and that is in contact with the H plus ions, Hc of HCl, that's 0.1 normal or molar, doesn't matter. And this is in contact with what?
Glass membrane.
Glass membrane. Very good. So this is in contact with the glass membrane. So this is how we represent the glass electrode. Okay, symbolically. So it contains what? AgCl electrode as internal reference electrode. Internal reference electrode. Okay, so it contains AgCl electrode as internal reference electrode. I can write IRE, internal reference electrode. It contains what? HCl solution, 0.1 molar. HCl, and it has got a glass membrane. Okay, it has got a glass membrane. Okay, which is very sensitive. Okay, when you say glass, okay, glass contains what? They are some sodium silicates, right?
Yes, sir.
Right. So silicates basically. So this contains what? This glass membrane is a thin walled glass tube with a bulb at the bottom, and it is made up of a special quality glass. What is that special quality glass? Sodium oxide 22%, calcium oxide 6%, and silica 72%. This glass membrane is made up of sodium oxide, calcium oxide, and silica in this proportion. Okay, it has high electrical conductance and can sense hydrogen ions up to 9 pH. pH 9. You may ask me a question, why I am writing up to 9 pH it detects accurately? Because see it, what it contains. Glass electrode contains
HCl.
glass electrode contains what? Na, sodium ions, right? So these sodium ions, when the pH is above 9, whether it is alkaline or acidic?
Alkaline.
Alkaline. In the alkaline pH, right, what are the ions present?
Sodium.
Sodium ions, right? So these sodium ions may interfere with our experiment, with our electrode, because this exchange reaction that is happening. This exchange reaction is responsible for that sensitive. It acts as a sensor because of this reaction to sense H plus ions. H plus ions replace sodium ions, okay, and it forms that glass electrode, okay. The H plus ions sit on the glass electrode and sodium ions come out, and again it reacts with this glass electrode, again sodium ion sits on the. There's a reversible reaction, and this is happening because of this. There is a potential developed across the membrane, okay. So if the a portion of the bulb is filled with 0.1 N HCl. Okay, silver chloride electrode is used as dip inside the glass electrode that acts as internal reference electrode. Okay, H plus ions, internal standard solution. Okay, HCl. Okay, 0.1 N HCl. It is internal standard solution, and this is called IRE, internal reference electrode. That is glass. That is silver chloride electrode. Silver chloride electrode acts as internal reference electrode, and 0.1 molar HCl acts as internal reference solution. Okay. So electrode is in contact with solution of unknown pH. If you want to determine the pH of any other solution, okay. So there is a solution here. Okay, you want to determine the pH of that external solution. This is what? External solution. So, right, what I do, I'll dip this glass electrode. Okay, and what happens? It develops a potential with respect to internal solution. As we know, it exchanges sodium ions with the H plus ions of internal solution. It also develops a potential with respect to what? The H plus ions of external solution. Do you agree? Because H plus ions are there. When we want to determine the pH, means it also contains H plus ions. Okay. So this is the glass membrane. I'm drawing it a little bit bigger here. Okay, this is the glass membrane. It contains internal solution, right? So glass electrode develops a potential with respect to H plus ions of internal solution. It also develops potential with respect to H plus ions of external solution whose pH has to be determined. Okay.
Yes, sir.
Right. So what happens if the concentrations, okay, if the concentration of H plus ions here is C1, if the concentration of H plus ions here is C2, okay, if the concentrations of hydrogen ions are different on either side of the membrane, glass membrane, the potential develops across the membrane. Potential develops across the membrane. This potential is known as boundary potential or junction potential. What is this potential? Boundary potential or junction potential. Okay. Why this potential is developed? Potential difference, why it exists? Because of difference in the electrode potentials. Okay. So internal reference, right, with the can you tell me NERNST equation for this potential developed with the internal solution, H plus ion solution? Anyone? I have written C1, so I'll take it as E1 is equal to what? E0 plus at
0,
298 Kelvin
0.591.
divided by N is 1 here because H plus ions log of
C1.
C1. Very good. Similarly, I can write E2 also. Help me.
E standard plus
E naught plus
0.0591
yes.
log C2.
Yes. Now, what is boundary potential? Potential developed across the membrane, that is E2 minus E1. Right? Now E2 minus E1, you tell me what I should write here. EB is equal to E2 minus
0.0
E1. Okay, this E0 you can cancel. Okay, 0.0591
log
you take
C2
it
by
outside. Okay,
Log C2 minus log C1.
all right, that we can do. Log
C2
C2
by C1.
minus 0.0591 into log, sorry, this is C2, this is C1, right?
Yes,
Yes,
sir.
sir.
Yes. Okay, so you write according to the properties of logarithm, you can write 0.0591 log of
C2
what?
by C1.
C2 by C1 or 2.303 RT over NF you can write instead of 0.0591. Okay, see, so what do you get? I have written there, okay, at 298 Kelvin I have written EB is equal to 0.0591 into log of C2 by C1. For any temperature you can write this. N is equal to 1 here, so I have right, first they have not substituted yet. Okay, so C2 is concentration of H plus ions, okay, into which the glass electrode is dipped. Okay, external solution, this is external solution. Okay, C1 is inside the bulb, internal reference solution. Okay, right, suppose here if the concentration of H plus ions inside as well as outside are same, what happens to the boundary potential?
0.
Zero. Boundary potential becomes zero. Yes?
Yes, sir.
Yes. But there exists some potential. Okay, if the concentration, when the concentration of H plus ions on either side of the membrane are same, no potential should be developed across the membrane, but practically some potential is developed. This is because of asymmetry. This is the electrode. Okay, external solution. This is internal solution, and this is external solution. Okay, there is a asymmetry. See, if I show you only the external solution, it will be like this. The symmetry will be like this. Okay, if I take only the internal solution, it will be like this. See the difference, right? Potential is developed here, potential is developed here. Okay, because of asymmetry, even though the concentrations of H plus ions on either side of the membrane are same, still there exists a potential due to what? Asymmetry. Okay, we expect it should be practically zero, but there exists some potential because of what? Asymmetry. This is called asymmetric potential. What is this called? Asymmetric potential. Okay, is that clear to you? So what is glass potential then? Eg. Now you should be able to tell me it contains what? boundary potential plus it contains what? Internal reference electrode, glass, what is that? Silver silver electrode is there, plus asymmetric potential is also there. When concentration of H plus ions on either side of the membrane are same, there exists some potential that is called asymmetric potential. So glass electrode potential is sum of all the three. Boundary potential, when the concentration of H plus ions on either side of the membrane are different, then there exists a potential across the membrane that we call it as boundary potential. Okay, that is given by E2 minus E1 that we have derived, and this is the equation. Okay, right. And asymmetric potential, when the concentrations of H plus ions on either side of the membrane are same, we expect there should not be any potential developed across the membrane, but there exists some potential that we call it as asymmetric potential. It is because of asymmetry. Okay, that also we have to include when I say glass electrode potential, right? Then there we use internal reference electrode. What is that? AgCl electrode, right? AgCl electrode, it has some potential. Okay, 0.1 N decinormal AgCl electrode, because you are taking 0.1 N HCl. Okay, so decinormal calomel electrode, silver electrode electrode potential you have to take. Okay, right. So it contains all the three. So now we have to solve this. Eg is equal to what? Boundary potential plus internal potential due to internal reference electrode, and potential because of asymmetry. So now you substitute the values. What is boundary potential? At any temperature, it should be 0.0 or 2.303 RT or NF log of C2 by C1. What is the right internal reference electrode? Potential due to EIRE and E asymmetry. Now you see, you can write this. Okay, first you write this. Okay, this one 2.03 RT or NF, you can write log of C2 by C1. You can write log of C2 minus 2.03 RT or NF log of C1. Now you see this, these three terms. One is electrode potential of internal reference solution. Okay, glass electrode developed with respect to internal reference solution. Second one is electrode potential due to internal reference electrode. That is what? Silver chloride electrode, and potential because of asymmetric potential. So you just see, these all the three are constants because we are using what? C1 is what? 0.1 N HCl. It's a constant. Internal reference EIRE, okay, glass electrode potential at right for 0.1 N Cl minus ions, it's a constant. How much it is? You might have written down earlier. Okay, it's a constant anyway, right? And asymmetric potential, okay, if you are using one when you develop an electrode, it's right, its geometry will remain same, so it's also a constant. All the three are constants. Okay, in mathematics, you know that all the three constants can be replaced with one more constant, right? That is, I'll define it as Eg naught. Eg naught is another constant. Its value is minus 2.303 RT or NF log of C1 plus EIRE plus E asymmetry, right? So I'll define one more constant. I'll call it a standard reduction potential of glass. Okay, standard reduction potential of glass. That's a constant. Okay, its value is minus 2.03 RT or NF log of C1 EIRE plus asymmetric. All the three constants I merged and I made one more constant. Okay, right. Now I can write. Okay, so what EG becomes now? EG is equal to 2.33 RT log C2 plus what? EG naught. I can write like this also. EG naught plus 2.33 RT. What is C2? It's also H plus N concentration only, right? We want to determine the pH, means you are determining the H plus N concentration only. So instead of C2, I'll write H plus N concentration. Now, what is pH? pH is negative logarithm of
H plus ion concentration.
yes, H plus N concentration. Okay, so I can substitute this here. So what happens in this? Log H plus becomes minus pH. Okay, if I take here positive, I'll make it as negative right here. So in place of log H plus, I can write minus pH. So this becomes like this. Equation becomes Eg is equal to Eg naught minus 0.0 right 2.03 RT or enough log of pH at 298 Kelvin. I can write this as Eg is equal to Eg naught minus 0.0591 into pH. Okay, this is the NERNST equation for glass electrode. If they ask in the examination, what is glass electrode? Okay, define. They may ask define ion selective electrode. Okay, the question, typical question will be define ion selective electrode. Okay, just read it properly. Okay, ion selective electrode. You have to define it. Okay, and then they may ask discuss the construction and working of glass electrode. Okay, then you have to do this. Up to here you have to derive, or they may ask you one more question. Instead of this, they may ask derive NERNST equation for glass electrode. Okay, so in that case, in all the three cases, okay, they may ask you discuss the construction and working. There are NERNST equation for glass electrode. Okay, in these two cases, you have to derive up to here. Okay, you have to start from here, glass electrode, and you represent symbolic representation, and this carries marks. Okay, 1 to 2 marks here. Okay, you need to write this entire thing and define what is boundary potential. It may carry 1 mark. Okay, and give this value. Okay, and then asymmetric potential, it may carry 1 mark here. Okay, what is Eg? It may carry marks. Okay, and finally you have to substitute and get the answer. It may carry 2 marks. So 7 to 8 marks, 6 to minimum 6 marks, maximum 8 to 9 marks you get for this. Okay, right. Definition carries 1 mark. It may get the other derivation carries 7 marks at least. Okay, 6 to 7 marks. Okay, construction and working. Okay, any questions here?
No, sir.
No, sir.
No, sir.
No, sir.
No,
No,
sir.
you understood?
No, sir.
Okay, so I'll go to the next. So if they may ask you how pH pH no, discuss or explain the determination of pH using glass electrode. Okay, they may ask you like this. Discuss the determination of pH using glass electrode. Then don't write all these things. Okay, you have to write only this part. Okay, whatever I am discussing now. Determination of pH using glass electrode. How you determine pH? Okay, I told you it forms. Right. Electrode develops potential with respect to internal solution, external solution, all those things I discussed. But how exactly you determine? Okay, determination of pH using glass electrode. You have to couple this glass electrode. This is your glass electrode, and this is your calomel electrode. You can use another another silver chloride electrode. Okay, but for theory, you just take the saturated calomel electrode. Okay, glass electrode, right? Potentiometer is required to measure the potential. Okay, glass electrode, you know, mercurous chloride, mercury, and this is platinum wire, and this is KCl solution, saturated KCl. Okay, and this is the solution of unknown pH. Okay, this is glass electrode. Okay, it contains silver chloride electrode, and right, potential is because of symmetry, and this potential is also because of boundary. You know, glass electrode potential contains what? What?
Internal reference electrode.
Yes, and asymmetric potential. So the value of this Eg is always greater than the electropotential of Se. We know standard calomel electrode. What is the potential?
0.24.
2 volt. Right? What is the potential of 0.1 and decinormal silver chloride electrode?
0.26.
How much it is?
0.26.
26. Okay. Right. And you have to add what to this? You have to add boundary potential plus symmetric potential. So first of all, it is greater than this. Okay. Remember, electrode with lower electropotential. Electrode with lower electrode potential behaves as electrode with lower electropotential. Means it undergoes oxidation quickly, right? Behaves as what?
No.
Anode. Electrode with higher electropotentials.
Cathode.
This is cathode because higher electropotential, and this behaves as anode. Anode we always write on the left hand side. This is anode and this is cathode. Okay. One question I'll ask. Electropotential of zinc electrode is minus 0.76. Electropotential of copper electrode is plus 0.34. Which acts as anode and which acts as cathode?
Copper is cathode and zinc is anode.
Be loud. Yes?
Zinc acts as
Is
anode.
anode.
Zinc acts as anode because it has got lower electrode potential, and copper acts as cathode
Cathode.
because it has got higher electrode potential. Very good, very good. So here, which acts as anode? Calomel electrode acts as anode because it has got lower electrode potential. Okay. So it has got how much? 0.242 volt. And this has got 2.26 plus E asymmetry plus E boundary potential. So definitely it is greater than, much greater than calomel electrode, saturated calomel electrode. So the given glass electrode is dipped in the unknown solution containing H plus ions, constitutes half cell. Okay, half cell means electrode. Okay, electrode is also known as half cell. Okay, and it is coupled with what? It is coupled with calomel electrode. Glass electrode is coupled with calomel electrode, which acts as a reference electrode. Its potential is constant. Okay, here it behaves as anode. Okay, reference electrode behaves as anode. How to represent the cell? Okay, here you have to start with anodic metal. Okay, anode metal is what here?
Calomel electrode.
Calomel electrode. It contains what? Platinum wire, right?
Yes, sir.
Yes, sir.
Platinum is in contact with, what is this?
Mercury.
Mercury, which is a liquid, and this is in contact with what?
Mercurous chloride.
Mercurous chloride.
Mercurous chloride, that is solid. Okay, mercurous chloride, through this opening, it's in contact with what?
Saturated KCl.
Saturated KCl. Right. So this saturated KCl through the salt bridge. Here it's a microporous plug is used as salt bridge. Okay. So we write double vertical line for salt bridge. Okay. Through salt bridge, it is in contact with the experimental solution. Okay. Unknown solution. The experimental solution. Okay. So, and this experimental solution is in contact with what? What is this?
Glass membrane.
Glass membrane. This glass membrane is in contact with what?
0.1 mHCl.
HCl. Okay. And this HCl is with
Silver coated with silver chloride.
AgCl first. Okay. Outside is AgCl. Okay. AgCl is in contact with what?
Ag.
Okay. You remember this diagram. Okay. You can easily, if you remember the diagram, you can easily write the cell representation. Okay. Just looking into the diagram, you can start with the anode first. Anode should be written on the left hand side. Cathode should be written on the right hand side. Okay, you have to start with the metal. Okay, start with the metal and end with the metal. Okay, anodic metal to cathodic metal. And you go through like this. Okay, as I told, platinum is in contact with calomel, Hg in contact with Hg2Cl2, that's in contact with the KCl solution. Through salt bridge, it is in contact with the external solution. External solution is in contact with the glass membrane. Glass membrane is in contact with what? 0.1 NaHCl, and that is in contact with AgCl, and that's in contact with Ag. This is how I represent the cell. Because if you write this, you get 1 mark straight away. Okay, in this one. Okay, right, this part and this part carries another mark. Okay, 2 marks are just writing these two. Okay, in the examination. Okay, what they ask? Discuss the determination of pH using glass electrode. Okay, how glass electrode is used to determine the pH? They may ask like this also. Okay, in continuation with this. Okay, so in the above cell, the calomel electrode behaves as anode. As I told you, why it behaves as anode, and glass electrode behaves as cathode because it has got higher electrode potential. The electrode with lower electrode potential always behaves as anode. The electrode with higher electric potential behaves as cathode. The cell potential may be determined using electronic potentiometer. Okay, and Eg naught. See, now, sorry, E cell is what? E cathode minus E anode, right? What is cathode? Glass electrode potential.
Glass
What is anode?
Calamel electrode.
Caramel.
Right. So substitute the value of glass electrode here. What is we have derived earlier? You don't have to derive. Okay, when they ask you how you determine pH using glass electrode, you don't have to derive that equation, NERNST equation. You can directly substitute here. Okay, Eg is equal to Eg naught minus 0.0591 into pH. This we have already derived here. Right? This is already derived.
Yes, sir.
Okay, directly substitute that. E cell is equal to, substitute the value here. Eg is Eg naught minus 0.0591 into pH minus E calamel. Let's keep it as it is, anode part. Now rearrange this. Okay, what is pH? Okay, first you take, okay, you take this Eg naught this side. E cell you keep it as it is. You take Eg naught this side. It becomes minus. Okay, and this you take it this side. Okay, E calamel. Okay, other side. So what it becomes? E plus E calamel. Okay, this is minus pH is equal to this. Divide it. Okay, so take it plus, you change the sign. This becomes minus, this becomes minus. So the same thing is written here. pH is equal to Eg naught plus Eg naught minus E cell minus E cell minus calamel. Okay, minus calamel minus. Okay, divided by 0.0591. So what is known and what are unknowns here? pH we don't know. Eg naught also we don't know. E cell we can measure it here using potentiometer. We can measure it. E calamel we know 0.242 volt for saturated calamel. This is a constant. So when there are two unknowns, what are unknowns? pH is also not known and Eg naught is also not known. So in that case, what we do? We take this Excel solution of known pH. Say I'll take 4 pH solution directly. I know the pH. I can write pH here 4. Okay, or known pH. Then I determine Eg naught. And anyway, you know Eg naught is the derivation
Constant.
constant. Very good. So once you determine Eg naught, that's a constant. Okay, then you can determine pH of any solution. Okay, the pH value of experimental solution can be calculated and determined substituting E cell, E calamel, and Eg naught in this equation. Okay, this is how we represent. This is how we determine pH using glass electrode. Okay. Okay. So any questions here?
No, sir.
Anybody else has questions?
No, sir.
Hope you understood what is glass electrode, how the NERNST equation for glass electrode is derived. Okay, what kind of questions they ask. Okay, in the first this one discussion. Okay, so what they may ask. Okay, here they may ask you define ion selective electrode. Okay, discuss the construction and working of glass electrode. So usually it carries 7 to 8 marks, 8 marks usually. Okay, or they may ask you instead of this, discuss the construction and working, they may ask you derive NERNST equation for glass electrode. In that case, you have to write all these things. This part, and this part up to here. Okay? Right? If they ask, discuss the construction working of glass electrode or derive NERNST equation for glass electrode. Up to derivation, you have to write here to here. Right? If they ask you how the pH is determined using glass electrode or discuss the determination of pH using glass electrode, then you have to couple this with calomel electrode. You don't have to derive that NERNST equation. Okay? You directly substitute here. Right? And get this. Okay? And what are the advantages? Glass electrode can be used to measure pH accurately up to 0 to 9 pH. Okay? And it can be used in the presence of oxidizing and reducing environments. And electrode is a glass, it will not be poisoned. Okay? And it is simple to operate, hence widely used portable instrument in various laboratory, especially pH determination. It is a common instrument used everywhere in the world. Okay, glass electrode. Any questions?
No, sir.
No, sir.
Archana, Yash, Sad,
No.
No, sir.
Omkar. Okay, if it's okay, I think now we have to stop here because you have got next class. I think you have to join. Right, just give your attendance in the chat box. I'll record it. Okay. Yes, thank you for your attention. We'll meet you tomorrow. Okay. I'll take that extra class for the last class which I missed. Okay. So if you have not understood anything, one more thing I can give you is my. Just a second. You can refer notes. You have to go to the site. All the class notes are available. Okay. You can get this. Okay. If you want, you can just refer that. Okay. But you prepare your own notes. Okay. They are just for reference. Is that clear to you?
Yes,
Yes.
sir.
You can go to that site and download whatever notes. Okay. Okay, I'll stop here.
Thank you, sir.
Thank you.
Thank you, sir.
And I again wish you a very happy and prosperous new year, safe new year. Okay.
Thank you, sir.
Thank you, sir.